All right, well, thank you everyone for coming this morning, and thanks for the snowflake welcome that it was 0 Fahrenheit when I got here yesterday, which I was telling everyone. I grew up in northern United States in the Northeast, so this is like my hometown. This is what it was like in the wintertime, this much snow. I took my driver's test in conditions like this when I was a teenager, so I happen to live in Texas now, which is in the southern United States, and it's significantly warmer there. But I still like the snow, and I like coming to see places like this and see something different. I was here in Helsinki 4.5 years ago, was the first time I ever came, and it was in June. So I've had the exact opposite experience, so now I've gotten to have both experiences here in Finland, which is great. A little more about me. I've been with Snowflake now for 3.5 years. When I started with the company, there was only 100 employees, all in the United States at the time, because we hadn't opened up in Europe until 1.5 years after I joined the company. I've been in the database and data warehouse space for almost 30 years now. I was an Oracle ACE director, did most of my data warehousing work in the Oracle space and a little bit in SQL Server, and then discovered Snowflake. And as they say, it literally changed my life. I was an independent consultant until I saw my first presentation about Snowflake, and then a couple of months later, I was a Snowflake employee. So that's why I like to give this talk, and talk in particular to architects and technical people a little bit about what Snowflake does and why it is so different. As I said, I've been in the database space for a long time. I'm also, I know some people here in Finland know about Data Vault, and I've been involved with Data Vault for almost 15 years. I co-authored the first 2 books on Data Vault with Dan Lindstedt, and actually I'm how he got introduced here to Finland, is when I came over. So Dan's a good friend. I've been involved with the Boulder BI Brain Trust, which was founded by Claudia Imhoff, and they do a lot of analysis on database vendors, and that was actually the second presentation I saw on Snowflake was when I was part of the Boulder BI Brain Trust, and Snowflake came to present the new technology to that group of analysts. And I actually got to be there in person in Colorado when they did the presentation, and that's how I met our CEO, Bob Muglia, was actually by attending that session as an analyst. He didn't know I had applied for a job. So we're going to talk a little bit about what the challenges are today, what is data warehousing as a service, which is one of the ways we refer to Snowflake, and then get into some of the interesting features of Snowflake that I think you guys will be very interested in. So we know the estimates are 40 zettabytes by 2020, and that's so we had terabytes, then petabytes, and then zettabytes. Right, so that's where we are. The data is getting bigger and bigger, and it's coming from all kinds of different places that we never thought of. When I started with data, there were no mobile phones, right? There was no real IoT. There was nothing like that. Well, actually, when I started, there was no internet. So data is coming from all kinds of places that we didn't expect. We used to just pull it from applications, primarily financial applications. Those who've been doing data warehousing for a long time. The first data warehouses were just financial analysis, right? A way to aggregate the data and do year over year, quarter over quarter reporting, and do it very quickly for the business people. And obviously that's changed and it's grown. And we've got so much data now. The challenge now is, what do we do with it? Big data and Hadoop solved the problem of, okay, we now believe we can store all this data, but what good is that data if we don't do something with it for the benefit of our customers, for the benefit of our company, for some reason, right? Why just store the data? Just because it's cheap and you can doesn't mean you should. So we're trying to figure out how do we take advantage of that data and bring insights to it. Forrester did a study that came up and said 73% of the companies that they interviewed aspired to be data-driven. My question is the reverse, is what about the other 27%? They don't aspire to be data-driven. They don't care about data. And I say those are the companies that are not going to make it the next couple of years. If they're not interested in the data that's available to their companies, their competition is going to end up beating them because their competition is part of the 73%. And I think you certainly want to be on the 73% side, not the 27% side. But of all those companies that are interested in using data, only 29% of them have been effective at it, of figuring out how to harness that data and do something useful with it in a timely manner to drive business decisions. And some of that has been because of the technology and the struggles that we've had over the years using the technology. I mean, all of the things that our customers complain about and our end users complain about, the reports are too slow, it takes too long to get the data in. What happens when you have to add a new system? You have a new source system. Say there's a merger, and maybe your company everything was on SAP, and you acquire a company that uses Oracle ERP. How quickly can you get that then into your data warehouse and start doing reporting on that across both systems? That's been a challenge. Being able to have enough resources available. How many of you have ever ran into the situation where you tried to run your ETL during the day and all the users started screaming because the query slowed down? The Tableau reports don't work. Well, the Tableau reports still work, they're just really, really, really slow. And that's been a challenge that we've had for many, many years. And that's all because of the technology and the way the technology was designed. The technology was all designed over 30 years ago, starting back with in the 80s where we had Oracle and DB2 and then eventually SQL Server. And those were designed for high-speed transaction processing, what we called OLTP. They weren't designed for aggregating billions of rows of data quickly. The first data warehouse I worked on was in 1995. And back then, doing a monthly update of the data warehouse was considered fast. Right, so we did every month, we got an extract from the finance system, and we ran all these different aggregates. We had quarterly, annual, we never did weekly. We never got down to weekly. The best we ever got to was monthly. And that was good enough for everybody back then. Obviously, that's not good enough today, but that's what the technology could support. And then along came Teradata for Teradata-sized data sets. And we went from hundreds of gigabytes to Teradata size bits of data. Specialized appliance specifically for doing analytics. And that evolved then further into Vertica, Greenplum, and I've got Hadoop up there, though I don't know that anybody really thinks Hadoop was a solution for data warehousing, but many of the vendors said it was. Because now we can store all that data that you say you want to do analysis on, and it's way cheaper than trying to store it in Teradata or Oracle, because it was very expensive to store all that data. So we solved the problem of, again, storing the data, but we couldn't actually access it, and people started having to write things like Hive to simulate SQL, because it was too hard to program MapReduce to get out the analytics in a timely fashion or expose it to, say, Tableau. People were having to pull the data out and move it into a relational database just so you could do what we'd been able to do for 30 years, just on more data. So the next evolution was then the cloud-based systems, data warehousing as a service that Snowflake evolved from. So definitionally, I wanted to go over what do we mean data warehousing as a service. It means it's data warehouse. It's not a general purpose database. It's not for high-speed analytic. It's for high-speed analytic processing, not for operational transaction processing. And so that's the distinction. And we get that question a lot, is why do you call Snowflake a data warehouse? Because by the time I finish talking to you, you will all say, well, that's a relational database. And indeed, it is a relational database, but it is a specialized relational database specifically for handling lots of data, high-speed loads, high-speed analytics, not for little, millions of transactions a second and processing those. So there is a distinct difference. And the as a service part is because it is in the cloud and it's delivered with almost no administration, similar to the way Salesforce.com works. That's the closest analogy, is you log in and you do your work. And that's why we call this a data warehouse as a service. So the company itself has been around now for 6 years. It was founded in 2012 by two gentlemen from Oracle. At the time, they had 120 database patents between the two of them, Benoit and Terry, who founded the company. And then with the founding of Snowflake, we filed 27 patents on the technology that is underlying Snowflake today. We're privately funded. So up now, we've got about $850 million in funding from venture capitalists from around the world who have put the money into the company to help us do the R&D and development and to build out the company as you see it today. As I said, when I started, there was only 100 people in the company. Now we're over 800 people globally, with our very first employee in Finland, having started, how long ago was it now? Couple of weeks ago, yes. After I had already we'd scheduled this trip, he got hired. He got started after we'd already scheduled this event. So we have new people every day. We had 23 new people start in London last Monday. And that's for all of EMEA, where a year and a half ago, it was 3 people. We started the office with 3 people and 1 gentleman from the US who moved over to help the company get started. We've expanded into Australia. We have a group, I think about 15 people over in Australia. I know we hired somebody in Singapore a couple of weeks ago, and I think we're about to hire somebody in Japan. So we're growing very rapidly. Some interesting things about Snowflake, to give you some context. Right now, our max day so far is we processed 100 million queries in one day across our systems. The single largest table in Snowflake that is 68 trillion rows. When I started, that same table, and I know which company it is and everything, it was 23 trillion rows. So in 3 years, they went from 23 trillion rows to 68 trillion rows, and that's actually a fact table in a star schema, just to give you an idea of what they're doing with it. The largest number of tables in a single database is 200,000 tables. Some crazy customer of ours put 200,000 tables in one database. Now, we can have a lot of arguments over whether or not that's a good idea. There might be some data governance questions there and, out of control data model, but you can do that. Snowflake really doesn't have any limits. Everything in Snowflake is effectively logical rather than physical. So unlike the servers that we have today, where there's a certain amount of space and a certain amount of compute, and the data dictionaries themselves even have limits as to how many things can you define and how wide can the columns be, how many columns can you have in a table, how many tables can you have in a schema. Snowflake doesn't have any of those limits. The single biggest customer has over 40 petabytes in Snowflake, and that's compressed. And the biggest customer has over 10,000 users querying Snowflake, and the record to date was 3,000 concurrent queries from that user, or from that customer. 3,000 concurrent queries wanting, but they actually have 10,000 people have access to the data warehouse. So when we talk about the concepts of data democratization, making data available to everyone in the organization, several of our customers have really gone down that road in a big way. Founder-wise, so our CEO is Bob Muglia, who he was the president of Microsoft Server Division, and in fact, he was the first programmer on SQL Server in 1988. When Microsoft acquired that technology, that database technology, and started turning into SQL Server, Bob was the first programmer. He's also the guy who was in charge when they invented Azure, which we're going to be talking about Snowflake on Azure. So Bob and several of our team members were involved in creating Azure. Benoit, second, and then on the end, Thierry, they're the two guys who came from Oracle. They built Oracle's optimization engine and the parallel query engine and parts of Exadata. So they were at Oracle for 18 years working on that, and they're the ones who realized that in order to take advantage of the cloud, you had to start over. The existing code base was designed for a very different world and very different types of hardware. And the things that we do in Snowflake could not easily be done in existing technology. It would require a complete rewrite. So rather than try to rewrite something, they started from scratch. And then Marcin, who invented vectorized query execution. Let's see, where's that database up there? VectorWise. That was his company. He invented that as part of his PhD thesis at the University of Amsterdam. And so that processing has gone into the optimization engine of Snowflake. So we've got this new approach to query execution from Marcin, combined with the knowledge that Benoit and Thierry brought from having developed the optimizations inside of Oracle and put all of that together with some additional innovation to create Snowflake. Their goal was to get a data warehouse in the cloud, specifically for the cloud, that would allow basically any company to work at any scale, no matter how small they were or how big they were, how much data they have, how many users they have, to be able to handle all of that in one place as a service with as little administration as possible. Some of the key differences for us is you can get all your data in one place, and I'll talk about that in a little bit, being able to have semi-structured data and structured data in one repository. To be able to scale it up and down on demand and support any level of concurrency that you're looking for, but with near zero management, without having to spend hours and hours configuring and changing things, to be able to do it with a simple command, some of which I'll show you. And then our live data sharing is a relatively new feature that's an adjunct to what we've done that grows out of our architecture, which is called the multi-cluster shared data architecture. And this is a new database architecture that Benoit and Thierry invented. So as I said, in the past, what I've generally been in my career is a data modeler and a data architect. So my take on this is, as a data architect, one of my challenges was always trying to build a data warehouse that would work, and then have to rely on, a lot of times, database administrators and systems people to provide me the hardware and the tuning and all of that, which made it difficult at times in order to actually grow a data warehouse. So there's a lot of really cool features in Snowflake that made, I'll say, my job much easier. And hopefully you guys will like this. So starting with number 10, I'm going to do a top 10 countdown. Snowflake works with all the tools that you currently use today. So we have open source ODBC, JDBC connectors, as well as an open source Python connector, an R connector, a Spark connector, a Node.js. There's a whole bunch of connectors out there, and they're all open sourced. So any tool on the market that uses one of those mechanisms for connecting to a database can immediately be used against Snowflake without a specialized connector. Now, obviously, if we build specialized connectors, it performs better. And so many of the major vendors in the data warehousing space on both the data integration side and the business intelligence and analytics side have native connectors now for Snowflake, where when you go in and want to connect it to a database, you click a drop down and Snowflake is there. And so they've taken one of our out-of-the-box connectors and optimized it for their product. If they haven't, if you find something new, you can still connect and still try it. Power BI is a great example. It started off with somebody at Microsoft actually wrote a blog post on how to connect Power BI to Snowflake using the ODBC connector. Now we have a partnership with Microsoft, obviously, and they're working on making a more optimized connector. Up in the corner there, SDDM is Oracle SQL Developer Data Modeler. My first week at Snowflake, I used our JDBC connector and connected the data modeling tool to Snowflake, and that was the first data modeling tool to ever get connected to Snowflake. And I wrote a blog post on it, so that was my first week on the job, is I figured out how to connect one of Oracle's tools to Snowflake and then wrote a blog post on how to do it. And that's now been leveraged by a couple other companies. A gentleman in Austin, Texas, wrote several posts now, he figured out how to connect ER Studio to Snowflake. We now have a partnership with Irwin, and Irwin is now building a connector to Snowflake. So there'll be a choice of data modeling tools that will now work with Snowflake. But that was something you would not have thought of, that a tool from a major vendor like Oracle is going to work against our product. But because it is open, we're able to do that. The undrop command. This is like my all-time favorite command that didn't exist in SQL, right? That we all wanted, but now we have it in Snowflake. You can do an undrop command. You can undrop a table, a schema, or a database by typing that simple command and hitting return, and within seconds, it's all back. So you don't have to worry about the backup and recovery anymore. We keep it online with a feature we call time travel that keeps track of the changes in your database for up to 24 hours by default. And at the enterprise level, you can go all the way to 90 days. And so any changes you make to the tables, to the structures, to the data itself, we keep track of inserts, updates, deletes, all of that, and allow you to roll back in time with a simple command. So undrop's the greatest one, in my opinion, because we've actually had customers use that. Because I'm sure none of you have ever had somebody go, oops, I thought I was in development. And they dropped a table, and it turned out it was in production. So this saves you from now having to go out and find the backup tape. Question number one, did the backup run last night? Or maybe it's, when did the last backup run? When did you do the drop? You don't discover somebody made that mistake till a day later. Do you have a backup at that time? Have you ever tried to restore that backup? How long does it take to restore the backup? Say it is only one table. How long does it take to restore the backup to get that one table back to where it was? It's now a matter of milliseconds and a single command with Snowflake. Zero copy cloning, which is related to the time travel features. With a single command, we can clone an entire production database. Hundreds of terabytes, petabytes, with a single command, and near instantaneous, and it's without copying the data. So it's doing a metadata copy. So part of our engine is this advanced metadata engine that has all the pointers to the files. So under the covers of every database, there's a file system, right? And so Snowflake has files, we call them FDN files, that we write all the data to. But we write them in an immutable form, so they can't ever change. And that's how we do time travel. Any changes to the data or the structure, a new file is actually written. But to keep track of all of that, the metadata engine has pointers to all of those files. So when you do a clone, you basically copy all those pointers and give it a new name. So how long does it take to copy the metadata? The first test I did was on a 2 terabyte database, and it took like 43 seconds. And so this gives you some incredible opportunities that do not exist in the current technology, in the legacy technology. With a single command, you can have a full production copy of your database for development, testing, for a sandbox for the data scientists, and not have to wait weeks and weeks for some sort of refresh process. Last time I asked a DBA to give me my development environment an update of data from production, it was 6 weeks. It was a 6-week process to pull a production copy, export it out to the file system, move it to another server in another data center, import it, and update the entire schema. And of course, during that time, my development was gone for at least 3 days for them to do the refresh. It takes 6 weeks before they could get there, but then it would be down for 3 days. Now we can do it in a matter of seconds. And this gives us opportunities that we've never had, like being able to do full production regression testing, not in production. When was the last time you heard of anybody doing query performance optimization against a full load of data. The best case scenario I ever had was my development and test environment were 10% of my production environment, which meant, as it turned out, about 1 in 10 queries and reports that we developed and tested, when we moved them to production, we couldn't meet the SLA because it actually required different tuning at that scale than what we were able to do in our development environment. And so with zero-copy cloning, we can do that instantaneously in Snowflake. Along with the time travel, one of the things you can do is you can actually create a clone at a point in time. So you can effectively do before and after images. You can run a process and take a look at what it looked like before the process ran and after the process ran and compare them. Because we can do these clones, again, at a point in time. We can even do them before a particular statement. Every statement in Snowflake gets a query ID. And so you can actually do a clone and say before query ID X. And it knows how to find all that data and then create it and copy it. Number 7, another one of my favorites, is the JSON support for SQL. When we started looking at the big data world, what people called unstructured data turned out most of the time was semi-structured data. Probably about 80% of it was actually JSON data. So when they built Snowflake, they decided, well, why can't we have a data type that supports JSON? And so one of the patents is on this data type called variant. And that allows us to load JSON and XML and Parquet and ORC and a bunch of semi-structured formats directly into a column in a table. So you create a table like you would in any database, but you can have now a column that has a data type called variant. With that, you can load that semi-structured document directly into the table without having to parse it out ahead of time into a bunch of tables and columns. Then under the covers, our optimization engine reads that data as it's being loaded in and logically parses it out, tracks where all the different keys are within that document, and stores that in metadata so that we can then go and write a SQL statement using a key name within the JSON document, and it knows exactly where that key is in the document. It's in a column and embedded in the document. So instead of having to do some sort of advanced indexing to know how you want to search the data, or having to do a fairly slow substring of a big clob, Snowflake goes directly to the document and to the key in the document, which allows us to have the same performance against a JSON document in a table as if it had been split into tables and columns. If you're interested in this, I did a blog post on this, and we also have an ebook that walks you through step by step how to access the data and what all the options are to do that. One of our customers has even gone so far as to write a set of Python routines that go in and recurse through the data in a variant and generate SQL views. And that's what many of our customers do, is in the end they go in, they use this technology to explore the data, figure out where the interesting pieces are in the data, and then they just do a create view statement and expose those views to Tableau or to Business Objects or to Power BI, and the end users never know that it's a JSON document. To them it looks like a table. And to the BI tool it looks like a table, and it performs like it was a table. And so this is allowing us to merge the best of big data with relational databases and data warehousing, and saving a lot of time, and a lot of time in developing all of that. We wouldn't be a very good data warehouse if we didn't have analytic functions. So we have a full library of ANSI standard SQL analytic functions, including all of your standard windowing functions like rank, lead, lag, and there's some really advanced ones in there as well. If you go to our documentation online, which is open and free, you can take a look at the SQL function library and see everything that's available in there to do your analysis. What that means is, in addition to being able to do advanced analytics, then all of the tools that support that sort of functionality can be used against Snowflake as well. Anything that you were able to do against a legacy database, you can do in Snowflake. In fact, we even have user-defined functions and user-defined aggregate functions. So one of our partners over in Ireland wrote this blog post last year on creating custom aggregate, user-defined aggregate functions using windowing functions. It's a real, and the title is literally, it's that long. He figured out how to do things that people in Snowflake didn't know how to do. When that blog post came out and we posted it internally, we had engineers going, wow, I'd never thought of that. So they built some features that now people have been able to leverage to do things that no one ever even thought of before. There's a lot of power. Our architecture, again, this is the key to Snowflake, is this multi-cluster shared data architecture. I already talked about our ability to take semi-structured data and structured data, store it in a single repository. We can join semi-structured and structured data together in one query because of that. But we're in a cloud-based storage which scales up and down. We tend to say on demand, but there's actually no demand. You load the data, it grows, you delete the data, it shrinks. So you don't even have to think about it. So you don't have to worry about, how much space am I going to need 5 years from now as I start on my data warehouse. I don't have to think that far out. It will grow with you, which really saves people a lot of headaches. Our compute. We've separated the compute from the storage. And what that means is that you can spin up multiple independent compute clusters of varying sizes to handle different workloads. So our examples generally have things like data transformation or ETL, queries, data science. No longer do you have to have and be concerned about those groups contending for the resources. We mentioned earlier our inability in the past to run ETL during the day without slowing down queries. Well, now you can have dedicated resources just for the ETL process. And that will not interfere with any of these other clusters that you've built. You see S, L, M, small, medium, large. Our sizing is, we call it t-shirt sizing, starts with extra small, goes up to 4XL. Extra small is a single node. A single node cluster, 8 threads. There's a certain amount of RAM. As you grow it, you get more. We also have a thing called multi-cluster warehouse, which allows us to scale horizontally on demand. So you can define one of these clusters to be multi-cluster and say it can go up to 10 parallel clusters. So in this case, I have a medium defined here for BI. When people start running queries, it will start off using just one medium cluster. As the queries start to queue, it can automatically add another parallel cluster and then load balance those queries across those two clusters. If the queuing continues, it'll do a third and a fourth, and go all the way up to 10. And then once the onslaught of queries subsides, they automatically turn themselves off, back down to your minimum, which is usually 1. And so once you've defined that, it doesn't cost you anything to define it. You only get charged when it turns on, and then it automatically turns itself off. So once you've set that up, you've got no administration. And it's a parameter in a command as to how to do that. It's very simple. The thing that holds it together is our cloud services or global services layer. And that's where all the the magic is. With our transaction management, we are ACID compliant. All the metadata, all the optimizations, the security, all of that is built into the cloud services layer, and that's how everything between the storage and the compute is managed. That's the place that keeps track of where are all those keys in the JSON document. How many nodes do you have available for your query, and how big is the data? Figures out how to stripe it across that real time. Have you run this query before? How recently? Is that data still in the cache? All of that is handled up in that data services layer. With this architecture, we can do what we've never been able to do before, which is support multiple workloads in parallel. And it's flexible enough that you can define any number that you need, and you can divide it up any way you want. We provide resource monitors so you can actually see what's being done in each of the nodes, each of the clusters, how many credits are being used, how many people are accessing it. So all the metadata is there to monitor everything that is happening. You can scale these up and down on demand. We have an alter warehouse resize command. And it is up or down, and it's milliseconds for it to change and to expand. And one of the really cool things is you can do it on the fly. So you can start a process, say on a small, and your boss says, I need the report by noon. This is something that normally runs 4 hours, and it's 10 a.m. You can alter that warehouse, resize it up to a medium, which doubles the amount of compute. The process will now run in half the time. And we have people do that all the time, and it costs the same because our pricing is per second, per node. So if it's half the time with twice the compute, it's the same price. It just got done sooner. So it doesn't actually cost you any more. In the end, what it does is it saves you time and allows you to meet a different SLA. And you can do it on the fly. You don't have to stop the query. You just do the resize, and the next statement that runs uses the expanded resources, and that database services layer knows that. It knows you just resized from 4 nodes to 8 nodes, and knows it now needs to stripe the data across 8 nodes instead of 4 to take advantage of the parallelism. So all of that is independent. So you can have, we call them virtual warehouses. I prefer to think of them as virtual compute clusters so as to not confuse myself. It's not a data warehouse. We just call them virtual warehouses. It is just compute. But it looks to the users as though they have their own data warehouse with dedicated compute, though the data is all shared. So you can have multiple groups accessing the same data at the same time. You can have your ETL process actually updating the database while people are querying it. And so we do read consistent views. You fire the query, it knows what the data is at that time, even though things may be going on under the covers. New data gets saved in the database. The next time the query runs, it gets the refreshed data. So you can actually be using compute to do near real-time continuous streaming of data into your warehouse while people are still querying. If you don't want the moving target, that's where zero-copy clone comes back in. We've had a couple of companies now that every night they create a clone of the production database. And all the finance reporting is done against that clone because they don't want the numbers changing during the day while they're doing their analysis. Imagine that. They want stable numbers. So they use zero-copy cloning to give the finance department basically a snapshot data mart while everything else goes on during the day. The data scientists may want a snapshot as well, may want a sandbox. There's other people that are doing operational BI. They want to see the changing data, and they're doing near real-time analysis. And all of that is supportable within this one environment. We can have one database with a single virtual warehouse working against it, or a single virtual warehouse working against multiple databases. It's all within your Snowflake account. We allow cross-database joins by simply saying in the from clause, database.schema.table. All it is a grant select. You don't have to set up any fancy links between servers anymore. You don't have to have physical access. You don't have to worry about the network bandwidth because it's all within the Snowflake ecosystem. So it allows you a lot more opportunities for granularity in how you want to design your databases. So in addition to that, with all the virtual warehouses, you can now have multiple virtual warehouses also against a single database for what I just described before. And they can all be different sizes. There's no restrictions on that. They don't have to all be the same size. Some of them can even be multi-cluster warehouse with all sorts of different users, resizable on the fly, multiple virtual warehouses against multiple databases. All of these are configuration options that this separation from compute and storage allows. And it is a brand new architecture. The last major architectural innovation in the database world was shared nothing. And it turns out that paper was written 30 years ago. So the Snowflake paper, which got submitted to SIGMOD 2 years ago, was the first major innovation in the database space in over 30 years. With this configuration, it allows us to provide real elasticity, taking advantage of the cloud. In our traditional world, you had to know and project what your usage was going to be, what your workload was going to be, what your data space was going to be required. And if you needed more, you had to buy more and alter your system. Either you had to buy a new box, or you had to buy additional components to add in, whether it's new hard drives, additional compute, and you had to plan all that out. Because in the real world, your usage varies, right? Black Friday is everybody's favorite example. You know, comes along and you get hit and systems crash because you had a really effective ad campaign and you really weren't ready for it. With Snowflake, that's no longer a problem. You use multi-cluster warehouse or alter warehouse resize. If the requirements are much higher than what you thought they were going to be, you can change all of this on the fly and you don't have to pay for it ahead of time. There's no reserved instances or anything like that. It's just you pay for it when you use it. You turn it on, you turn it off. We have auto suspend and auto resume. So you can set each of these compute clusters up with an auto suspend parameter. If nothing's happening for 5 minutes, turn off. In auto resume, the next query that comes in automatically turns it back on for you. So again, that's the zero administration. You do set it up and put the parameters in, what are the guidelines, but once you've done that, you can forget about it. And the pricing, because we're working at a large scale, the pricing has come down significantly. We're down to, on AWS, it was $360 US per terabyte per year. And that's compressed. Most of our customers get anywhere from 3 to 5x compression. So if you have 5 terabytes of data in Snowflake, it ends up being 1. And you pay for the compressed number, not the uncompressed number. I was working in healthcare for 5 years prior to coming to Snowflake, so the security definitely got my attention. I found it nearly impossible to get DBAs to use encryption on their databases because 1, it slowed down the queries, and 2, the vendors charged a lot of money for that encryption option. Snowflake was designed from the beginning with the security in mind. The encryption was built in. We use 256-bit AES encryption. The data is encrypted in motion as you're uploading the data to Snowflake. It gets encrypted before it leaves the source as it's being loaded into Snowflake, and it's always encrypted at rest. And we have a hierarchical encryption schema of keys, encrypting keys, all the way down to the files, along with key rotation. So every month, the keys are changing. So even in a single table that has grown over time, the encryption key for the data that's come in at different times is actually different. There's a really good blog post on that as well that explains the entire hierarchy and how it's done and what we do with it. And that really impressed me, the fact that you could do it, that it didn't slow down the queries, and in fact it's not even an option. Because we had people say, well, can I turn encryption off? Because of course it's slowing your queries down. Well, no, not of course it's slowing your queries down. That's what the old technology did. Because the old technology wasn't built with encryption in mind. Where Snowflake was written from scratch, it's not based on any existing code base. They didn't take Postgres or Oracle or SQL Server or any existing database code and make changes to it. They actually started with no code and wrote a completely brand new relational system, which is why we can do these sorts of things, that it could be built with the encryption baked in, and why we could do the multi-cluster shared data and have a new architecture, why we could do time travel and zero-copy cloning and JSON in the database. Is because when you start over, you can make it do whatever you want. And that was the vision of the founders, was looking at the data warehouse space and what the challenges had been for the last 20 years in data warehousing, and saying, well, how can we fix that? How can we take everything we've learned about big data, everything we know about relational databases, everything we know about data warehousing, and everything we know about the cloud, and put it together into a brand new product? And that's what we've gone and done. With that, we've got all the certifications for HIPAA, which is the Healthcare Protection Act in the United States, PCI, which is certification for financial data, so for credit card data, and then SOC 2 Type 2 compliance as well. And of course, we have all the standard role-based access control, so you can define roles and who has access to what, who can insert, update, delete, create. All of that standard stuff is there. Federated authentication, multi-factor authentication, so you have an option to turn that on. We use Duo, so somebody logs into Snowflake and they get pinged on their cell phone for an access code to make sure that they are who they are. The automatic query optimization, again, this is number 2 on my list because this was my biggest fight as a data warehouse architect. Always ended up being with the DBA and trying to get the DBA's time to make the queries go faster. And that's all gone because Snowflake has a dynamic optimization engine built in that runs off of metadata. As data is loaded into Snowflake, we automatically gather the statistics, and so they're always up to date. They're never behind, and there's nothing you can do to turn it on or off. We just manage all of that for you, so that every time you run a query, the most current information about the size of the data, the structure of the data, the domains of the elements within the tables are all recorded in metadata already. So we can generate the most optimal query plan for you without you having to do anything. And then data sharing. Because of our architecture with this separation of compute and storage, it's now possible for a Snowflake account holder to become a data provider. So effectively, we call it a secure data share. To me, it's a curated data mart. You define a set of data, a set of tables, a schema, or maybe even an entire database that contains data that you want to share with a downstream consumer, which could be a business partner. It could be another division of a very large company. There may be multiple Snowflake accounts. It could be your customers that want to pay for access to some level of data, whether it's their data they've given to you and you've augmented it, or it's some new analysis, or it's some data set that your company owns that you want to monetize. You put it into a data share, you grant access to other Snowflake accounts, and they effectively now have a read-only view of that data set. They use their own Snowflake warehouse clusters to access it. So you've stored the data in one place. So we've eliminated the need to move the data around, to export the data, put it on a secure FTP, have somebody import it, and then load it into their own data warehouse. And both sides are having to maintain and manage code sets. And of course, if you want to change it, then you've got all the usual development lifecycle things of, okay, we changed the schema, we got to change the ETL code, we got to change the extract code, they have to change their import code and their ETL on their side. All of that goes away. You may change the schema, but as soon as you change the schema and make it available, they see the new schema. Now it's just metadata, right? We added 3 columns, we added a new table. That's all you have to do. And you've eliminated all this back and forth and the lag. As soon as you update the data in your account, the share sees it, the consumers see it. So instead of having a monthly refresh cycle, you can now have a daily refresh cycle or an hourly refresh cycle, depending on the nature of the data. So this is creating many new opportunities for people to take the data they have, share it downstream. The consumer could then take the data they have and use it to augment the shared data into a new data set that they then share downstream. And I've still been meaning to update this diagram because it can go both directions. We have some companies that are doing bidirectional sharing. They share a data set to their partner augments it and shares the augmented set back to them. And this is really creating some interesting opportunities for people in doing things with data that they never thought they'd be able to do. When I first started in data warehousing, people always used to talk about getting external data sets. Is how do we enrich our data? I think that was the term we used, is enriching our data set. Well, this gives us a mechanism to now do it very easily. One of the first customers we had was Snagajob, which is an organization in the US that does basically job postings. So you subscribe and say, I want to know about data architect positions in Houston, Texas. And you would automatically get emails as new jobs were posted. And that was through this company called StrideSpark. So Snagajob would get the listings, create the data set, export it, send it to StrideSpark, and then StrideSpark would send out the emails. Well, they eliminated the data pipeline completely with data sharing, so as soon as that job now gets entered into Snagajob, StrideSpark sees it and can send the emails, which means their time to market is faster than their competition. Because as we know, most companies, when they post jobs, they don't just post it in one place. So the person who gets it out to the candidate first gets the referral fee. So they've now optimized that data pipeline through data sharing. Saved themselves all kinds of time, money, maintenance. Nielsen in the US, they're the poster child for data sharing. They invented data sharing 100 years ago with a paper process on TV ratings. Right? They're the guys that put a little box on somebody's TV and did surveys to say which TV shows are you watching, how long did you watch, and the sets track when people change their channels, how long did they stay on that channel, on that show, did they flip it off during the commercials, did they flip back, all of that's tracked, and so they've been selling that data for 100 years. Now they're doing it with Snowflake, and they're able to now share the data instantly with their consumers that are buying that data. So eliminating this, again, the pipeline, what we used to call EDI, right? Exporting the data into a fixed format file, somehow getting it to the customer, and they get it into their system. So what people are doing today with Snowflake is all over the place. At the forefront, NoSQL replacements. Getting rid of Hadoop, Mongo, other NoSQL systems that they were using strictly for storing and processing JSON data, just to turn it into relational data and loading it into a traditional database in order to do analytics. They're able to do all of that now inside of Snowflake. We have companies that are creating their own products on Snowflake, their data warehouse offered as a service. So they're actually analytics systems as a service where they're taking data from a bunch of organizations, a bunch of customers, putting it together, doing some aggregates, doing some interesting analytics on it, and then exposing that result set back out through a portal. And under the covers, it's being driven by Snowflake. And then the traditional, I'll say, data warehouse modernization, contracts up on your Exadata box, your Teradata box, your Netezza box. What are we going to do next? Okay, well, we're going to go to the cloud. So what are we going to use in the cloud? And they're looking at Snowflake to do that, to get off of those on-prem, very expensive boxes to move their system forward into the cloud. The results that people are getting are basically mind-blowing. At least they were to me when I saw it. So one of these examples of the NoSQL simplification, one of our companies had an 8-hour process to prepare the data. When they moved it to Snowflake, it went to 1.5 minutes. So instead of having to wait all day for the JSON data to get all parsed out and put back into a relational database so that the analysts could eventually see the data, they just load the JSON straight into Snowflake and have built views on it. So the 1.5 minutes is how long it takes them to load their current data. And as soon as it's there, people can start querying it. The faster analytics, someone going from, again, an on-prem system into Snowflake with a 20-plus hour processing cycle for their analytic reports, running the same report in 45 minutes on Snowflake. And then cost-wise, looking at replacing, well, we'll say upgrading an on-prem appliance to get the better performance, to get the newest version of the machine. One of our companies was looking at $5 million to get the next release of what, and I can't remember if that was an Exadata box or a Teradata box. It was one of those two, I'm pretty sure. And they were able to do that with Snowflake for $50,000, so a lot cheaper, and add 2 new workloads. So even with their new $5 million appliance, they weren't going to be able to do these 2 additional workloads. It was just going to get them to getting good performance on what they were trying to do today. We have over 2,000 customers globally now. You can see some of the logos there. There's lots of case studies out on our website in the resources page. Just a couple of quick ones. Double Down, which was an early customer. This is the NoSQL poster child. They had a series of NoSQL databases, which I believe were Mongo, using MapReduce to cycle through event data. They had to do a lot of processing to break it out, put it into flat files, and then they aggregated it into an enterprise data warehouse that the BI analysts could have access to. The problems were that system kept breaking all the time. It could take anywhere from 11 to 24 hours to get yesterday's data accessible to the BI analysts. And they could only, their data warehouse was so limited, they could only store the aggregate data. They were throwing away the transaction data, the detail data every day. They'd go through this whole process, aggregate it, and then have to throw it all away because they couldn't afford the space. With Snowflake, they switched over to using, they were on AWS using Kinesis, loaded all the detailed data into Snowflake using the variant, then aggregated it to their existing EDW so they didn't have to change what the end users were seeing and working with. But then they were able to add the additional functionality that if the analysts wanted the details, they could drill down and drill into the detailed data, which was stored back in Snowflake. So from 11 to 24 hours down to a 15-minute process that they don't have to do any maintenance on. Cap Specialty, which is a specialized insurance provider, they got 120 times faster performance. Their process went from 20 hours to 45 minutes in the pipeline that they had. And they said, yeah, anywhere from 1 to 2 days to get it available to MicroStrategy, and we're able to drop it down to a couple of minutes to get the data loaded in Snowflake and have it accessible. And yeah, when they went live, yeah, they deployed in a week during their busiest time of year and had their production environment up and running. Then White Ops, which does online fraud detection for websites. Their system, again, using Mongo, S3, and Hadoop, making a lot of data available for the data scientists, but only the data scientists could get to it. If a BI analyst wanted it, they had to actually go to the data scientist because they had no ability to access the data in these environments. And it was a 24-hour turnaround. One of the things they build is fraud detection models. So as they're getting new information from their customers as to what's happening on their website, their data scientists are coming up with new algorithms to see new patterns in fraud. And it was taking them 24 hours to do that. When they went to Snowflake, they got it down to 2 hours to push out a new model live, and they used zero-copy cloning to make snapshots of that data available directly to the analysts, as well as using multiple warehouses so that their data scientists could be doing their work and developing the new models while the analysts were able to do their reporting all against the same data without any contention. Some of the big names that have come to the table is Snowflake. Adobe's been one of our customers. The 68 trillion row table is theirs, that they've been growing and growing and growing. Every Friday they load 100 terabytes into their database. Every Friday. Nike, PDX is a really interesting one in Dallas, Texas. They process and collect all the data from 11,000 pharmacies across the United States and aggregate it and turn it into analytic marts and then share that back to those pharmacies so the pharmacist at each individual pharmacy has a view into what's happening in their pharmacy, what their inventory levels are, what their sales were the day before, a lot of analytics that they've built for them. Capital One moved from, well, Redshift and Teradata into Snowflake. They, a couple of months ago, decommissioned their first major Teradata system. Has all been completely moved over to Snowflake. Nielsen I already talked about, and then Charter Communications in Denver, replacing Netezza with Snowflake. We have also Sony Entertainment in London is moving off of a Netezza box. We're 3/4 the way through that particular project. And any number of other organizations that are moving off of these big legacy systems into Snowflake. And so that's our conclusion. You know, big data does not have to be a big effort. And that was it.